Thank you very much for your introduction. It's an honor for me to be here in beautiful Spain. Buenos dias, Sevilla.
Bonjour et bienvenue. Herzlich willkommen, Hello again and welcome to my presentation about TeacH2 Tomorrow, hydrogen as an alternative energy carrier.
Today's journey starts from hydrogen, science or fiction, to tomorrow's innovative technologies to decarbonize the mobility sector, and the principle how to bring these technologies in science teaching. 3. I give you an insight about the problems which inspired me to my research projects in the context of energy transition to make a change in science teaching. Then 4. I would like to show you one of my teaching series with a focus on hydrogen. 5. The experiments embedded into a narrative to guide students through how hydrogen could be an alternative to fossil fuels, and an excerpt of a student's learning video. And last but not least, 6. A special evaluation with concept maps. And where do we get our energy from, if not from coal? One of the two stranded protagonists asks the other. From water, answers engineer Cyrus Smith. This is not a dialogue from current politics, ladies and gentlemen. Jules Verne is considered one of the founders of science fiction. In his amazing novel, The Mysterious Island, he describes the use of water by splitting it into its elements to produce fuel, exactly 150 years ago. Today, we are globally getting ready in politics as economically to focus on hydrogen technologies and their infrastructure. So to answer my question, it's both. First fiction, now science. So let's see. What kind of technologies are there? Airbus promises a zero-emission plane by 2035 with hydrogen technology, either through 1. Internal combustion engines, or 2. In fuel cells. Now, how to make them understandable for students? According to TeacH and Banerjee, these complex research technologies should be converted into simple model experiments following the 5 low principles: low cost, low risk, low time, low tech, and low energy. So, after so many lows at a time, no worries, the experiments are high fun. There are innovative concepts like the construction of solar cells as hands-on experiments already. These require understanding of complex topics and are taught in higher grades. My intention is to link existing themes of curriculum in a new way with some additional content in lower grades. The context of my concepts is basic knowledge relevant for the energy transition. These should be taught subsequently as a spiral curriculum built by 2 pillars as solid fundament on basic properties, see on the right side, and later on basic technologies, see on the left side. These concepts build additionally a bridge to complex higher education themes. As an example of testing basic properties, I add to the usual testing of conductivity of materials, the testing of semiconductor materials like silicium and germanium. The teaching series on basic technologies will be explained later on. So, why are these topics so important? It is important to establish learning about these topics earlier from a beginner's point of view for better understanding, because it is in our hands to teach tomorrow's politicians, managers, journalists, as scientists of the 21st century. There are 4 units of my teaching series with some low-tech experiments. 1. We start with a simulation of the internal combustion engine, still largely used in cars as in planes. So using them with renewable fuels means conserving resources, and running systems could be retained. Then 2. We have a look at carbon-containing and carbon-free energy carriers, combustion gases. 3. Hydrogen production and use in a TeacH2 shell. 4. Discussing the topic of whether or not hydrogen is an alternative to fossil fuels. So let me show you an excerpt of the experiments of my teaching series. This is a well-known and popular experiment to model the combustion in a chips can. My students first carried out the experiments. Then they watched an animation of the 4 strokes of the internal combustion engine. Afterwards, they had to draw parallels and discuss differences to the 4 phases of the experiment, illustrated on the worksheet. And here I use a smaller chips can as an analogy to the internal combustion engine of the previous class. We demonstrate the combustion of a renewable fuel tested in current research to make sure hydrogen is an alternative to fossil fuels. So you can call Airbus that it works, but they should use hydrogen gas carefully. This is a teacher's experiment as it is dangerous and loud. However, we see that hydrogen too can be used for the internal combustion engine. To show whether the combustion gases contain carbon dioxide or not, I use a simple syringe to withdraw the reaction gases. On the left, you see the positive test from the student experiment with fossil fuel, containing carbon in its formula. The precipitate indicates a positive test of carbon dioxide in its combustion gases. Using hydrogen as an alternative fuel, students observe that no precipitate is built, and we conclude that we got rid of carbon dioxide. So here the good news. So far, hydrogen seems a good means to decarbonize the mobility sector. Usually, we use the complex Hofmann decomposition apparatus for water electrolysis. During pandemia, our team developed these experiments in lab at home after the law principles, and so here I show you now how to build the TeacH2 cell. After you have consumed the contents, sacrifices have to be made, and removed the label, heat an iron nail at a tea light, perforate the bottom in 1 centimeter distance for the 2 iron nails as electrodes. Seal the holes with adhesive pads. Attach some copper foils as contacts, and the low-cost electrolysis cell is ready. This experiment was invented by our team to mimic electrolysis and fuel cells with simple household items. And now I would like to show you how the small low-cost electrolysis apparatus works with the simplest materials. And you can see on the right side at the cathode how an obviously larger amount of reaction gas is collected in the aroma vial as a mini test tube, since twice the volume of the reaction gas is formed at the negative pole, the cathode, within the same unit of time than at the positive pole. So the process of electrolysis can be observed here as a low-tech student experiment. I will explain the solution to the mystery later with the help of a small animation. And with the help of some foldback brackets, the little test tubes enable students to carry out the oxyhydrogen test low scale without any danger. As hydrogen has a lower density and escapes easily, we hold the small test tube with the opening facing downwards and carry out the detection reaction from the side. PowerPoint animation improves understanding via simple visualization. See Banerjee. For this purpose, the macroscopic level is taken up again in the model of the electrolytic cell. In this way, the focus is placed on one part of the observation. This is then simply explained at 2, the submicroscopic level, with only 2 water molecules shown as particles. The red circle stands for an oxygen atom, and the smaller white circles symbolize the hydrogen atoms. In the next step, the splitting of the 2 water molecules into the elements is shown. On the left side, you can see 1 oxygen molecule, O2, and on the right side, 2 hydrogen molecules, 2H2. This way, we can make the 2-to-1 ratio of hydrogen to oxygen in H2O visible. With few grips, I convert the cell into a fuel cell by putting a piece of sponge in the middle, attaching 2 small pieces of stainless steel wool to the nails used for cleaning pots to increase the surface area. This time I'm using a solar cell as a sustainable energy source to charge the fuel cell according to the power to gas principle, like you have seen at the electrolysis, but the gases are captured in the wires. Now I remove the solar cell, and the gas bubbles are trapped in the wool. At the electrodes, when a small motor is connected, chemical energy is converted into electrical energy again. And you see, Airbus has now some new little engineers for the research and development team. At the beginning of the teaching series, students build groups and share their tasks for their self-created learning videos. They organize their responsibilities during their projects for themselves as film crew members and are aware of the film awards coming up at the end of their project. At a small film awards ceremony, we select in class the best science director, the best experiment director, actors and actresses, creative director, camera staff, sound director, and the best team. This little storyboard helps students to structure their knowledge they gather during the teaching series in an open way. And here comes a little excerpt of students' self-created learning videos as product of their accumulated knowledge, which turned out as highly motivating, and students would do their best. More than that, they even mentioned today how it helped them to overcome shyness to present their knowledge in presentations.
Und jetzt zeige ich euch das Power-to-Gas-Prinzip. Wir haben hier die Solarzelle und hier die Lichtenergie. Dieses wird umgewandelt in elektrische Energie und das führt auch zu chemischer Energie und dadurch entsteht Wasserstoff.
And last but not least, I would like to show you an excerpt of the evaluation tool. I've chosen some of the most important expressions of the context of energy transition. Not all of them were discussed in class, so what I wanted to do was to test how students would connect information before and after my teaching series with pre-tests and post-tests with the so-called intra-co maps. And here you can see an example that my student marked many more terms in the post-test in green for having understood, no one in red for not having understood, and less with yellow, expressions heard but not fully understood. The method of creating concept maps was practiced before in order to measure only the increase in performance during the series of lessons. They should put the terms in relations to each other, and you see either an improvement in the number of expressions understood as well as many more relations between expressions and higher complexity in students' wording. Here you can even observe a larger handwriting due to the analog method, which indicates greater self-confidence in terms of knowledge in the post-test. And as you see, I'm still working on how to help Airbus with my fuel cells. So far, I achieved to move a little car when using 4 parallel connected TeacH2 fuel cells, and it looks like I will need a huge stack to achieve flying.
Okay, es ist gefahren.
And here on the right, you see the 5I models still in development of our work group to structure our research project into phases. So far, my research projects have gone through the first 3 of the 5 phases of inspiration, invention, and through 2 cycles of investigation for my teaching series. Innovation will be coming up through student lab and teacher training. Finally, there will be an implementation phase in which teachers will independently test my concepts themselves. I'm looking forward to an international exchange coming up. Please do not hesitate to visit our project website at www.banerjee-lab.com/teach2-tomorrow/. I would like to give my appreciation to Professor Banerjee for his great support, to whom I owe to be here today. Many thanks to Dr. Yolanda Hermans for the inspiration and support with the evaluation method. Many thanks to our team in Potsdam and to the Potsdam Graduate School and my high school team. Thank you very much for your attention.